Hey, can you hear me? Hmm. Ah, okay, cool. So, we have someone sleeping here. Okay, so it's a mentorship session, and you can ask any question that you have. If you don't have questions, I have a talk that I can do. But I think maybe some of you, if you have a time to check the repository and everything, you might have some question, or from already what we've talked about. So yeah, let me know. If you don't have questions, I can go, like I have a presentation I can do. So, and I think that will probably spark some question. So, so feel free to stop me at any point if you have a question. And so I'll talk about the beast, like the core of all of what we're doing. So we have talked a lot about ICP, internet computer, but we haven't properly explained what it is. So I'm gonna take this session that we have and try to explain what is all of this. So there is this kind of image like shot that I like to look at, and it's kind of promotional, like of course, but it's also putting things into categories. And so the way I see the crypto industry, there are many innovations happening, but I think the two big ones that we had are like Bitcoin and Ethereum. And so Bitcoin gave us the first cryptocurrency, so we could finally send money without any central intermediary. Then we had Ethereum, and that's when we started to see really a boom, because we had this time programmation. We could do smart contracts. So smart contracts, if you have never coded in Solidity in Ethereum, basically you can say, it's like Bitcoin, but you can program how the money will behave. So for example, you can say that if I send money to this address, then I will send half there, half there. So you can start to play with the concept of ICOs, for example, so raising money through a token. You can start to play with decentralized finance, and you can start to play with a lot of things. And then ICP, so Internet Computer, is in another category because it's really at the frontier between a crypto project and a cloud project. So everything that you can do on Amazon Web Services or Google Cloud, you should be able to do on ICP, but it's a trustless cloud, or I would say, to be more precise, it's a cloud trying to become a trustless cloud because there are still some gaps that we can talk about. But essentially, that's the vision of the project, is to create this environment where you can deploy applications and you don't have to trust one company. So that's for the context. And so ICP, so Internet Computer Protocol, ICP, there are three kind of different concepts that each are related to the other. When I say in the Internet Computer, I talk about the network, so the cloud that we can deploy on. When I talk about ICP, usually it's the token. So ICP is the token. And ICP, so Internet Computer Protocol, is also actually a program, like a piece of code that that a computer can install and run. So those are three intertwined concepts. Of course, if you don't have the program, you don't have the network. If you don't have the token, you don't have the network. Like, all those concepts are related, but they are not exactly the same. And so the network, it's this cloud where we can deploy applications. So two examples are OpenChat running on this infrastructure. Discover is another one. So all the things you see here, the backend, frontend, images, the messages, they are stored on a container that runs the application. And same thing over there. So traditional cloud, you can deploy and run applications. The token, it's like any other cryptocurrency that you know. You can buy it on exchanges. So you could buy on Kraken, Binance. Not financial advice, of course, but it's just like any other token, and it's listed on exchanges. You can trade it, sell it, buy it, and so on. The token, how is it used in the network? It's used in different ways. The first way is that if you want to build on the network, you need to buy the token. So you need to buy it because you go on exchange, you buy your ICP, and then you burn it, and that's how you run your containers. So the applications, like the containers, they require you to put credits inside. It's called cycles, but let's say credits. And those credits, they come from the ICP that you burn. The second way is if you want to get invested in the network, you can stake ICP. And so that gives you first interest. So you have interest when when you stake them, you have interest on your ICPs, and then you can also vote on the direction of the network. So yeah, there are proposals about what features, where should the network go, and everything is done through a DAO. And the DAO, of course, ICP is the currency of the DAO. So that's the two sides of the token. Next, we have the program. So the program is this repository. It's called, so Definity is the foundation that created the IC protocol. And so they have this repository, which is the main one. It's an open source repository, and you have essentially all the code that runs in those machines. So that's like one picture from a data center that has one of those nodes. It looked like this. It's I think it's one of the first that was in the network. And yeah, like it's basically just a piece of code that runs on a computer. And so this code is currently maintained and improved by Definity. So Definity is the foundation that you see here with the logo here. The idea is that this should be like open to contributions from the external world. So that's what I was talking about when I say the IC is a cloud to be decentralized, because right now I don't think there are good, solid examples of other entities that contribute to this code. And that's mainly for technical reasons, also for economical incentives, of course. But like, yeah, like this should be open, and this should be something that anyone could contribute if they have the resource and the expertise to do so. So what does all of this do? Well, you have the nodes. So the one I've shown in the pictures, the data centers, you have scattered all around the world. You have nodes in America, Europe, of course, Asia, South Africa, South America, and oh, what's happening? And so those nodes, they are really the base of the network. Like without them, there would be nothing. Then, of course, those nodes, they use internet, so they are connected over traditional internet, but they all run this ICP protocol. And so combining them, essentially, you create this network called Internet Computer, where you can run application. And so as a developer, we will work here on the application side. But of course, this means that you have all this stack that basically makes building on the IC possible. So a good recap of what we've talked about is we have the nodes, basis of the network. Then they run this protocol, and this makes the top layer possible. So the network is possible because of this. And the application layer, I don't know. The canisters is the application. So those canisters, that's where you deploy your code. That's where you build applications. How is the network structured? The network is divided into subnets. So essentially, you have multiple nodes that collaborate to run one subnet. And then each application is deployed in one subnet. So think of a subnet as like an island of consensus. So all the canisters in one subnet are replicated across multiple nodes. And whenever you do an update or like you modify the state of a canister, you modify the state in all the nodes, and then they come to an agreement through a consensus. So that's why it's decentralized, why you can trust the canister, because you don't need to trust this node or this node. You essentially need to trust that there are enough nodes that you can be confident with your application. And so, yeah, there are probably 35 subnets at the moment, 36 subnets. When you deploy an application, you are automatically going to be deployed in one subnet, and you can choose that. But yeah, basically, a canister is always in one subnet, not in multiple subnets. So what is a canister exactly? Oh, this is, I don't know what it's doing here, but this is a message from, I don't know what's doing here. It's a message from one person that got me involved in this ecosystem. I don't know what's doing here. It's so strange. Okay, so canister is a container for your application. And I'm sorry, wait. The animations are. Okay. I will do it without the animations. So a canister is a WebAssembly module. For WebAssembly, you can compile to WebAssembly from any of those languages that are supported on the IC. So this week we are focusing on Motoko, which is a beginner language to get started on the IC, but you could also use Rust. So some students over there are building with Rust. You could use Python, and you could use TypeScript to build a canister. So there are some differences between them. Mainly TypeScript and Python, it's a trick because they don't really compile to WebAssembly natively, but they have a compiler that compiles to WebAssembly. So you're basically running a full like TypeScript or JavaScript engine within a canister. And so you can write in TypeScript and have your code in a canister. Motoko is really the language customized for JIC. So if you want to be committed and build on this platform, this is the language that you have the most, not capacities, but the fastest, I would say, and also the safest, and also the easiest to learn. And then Rust is probably the one that is the most used today because it's a mature language, of course, and it's also used in like other blockchain ecosystems a lot. So Rust is also very, very cool. And So how do we interact with canisters? As a user, every time you are using an application on the IC, it's basically a message to a canister. So for example, if you're transferring token, there will be a function in the canister that will be called transfer token. You just call this function, gets executed, and that's it. That's how like things work, basically how you use web applications on the IC. Good thing to know, interesting thing to know is that canisters can create other canisters. So you can build services that would have multiple instances. For example, that's how OpenChat grew their application. Every time you deploy, every time they have a new user, they create a canister for this user. So it's essentially like your virtual environment for yourself that you can use. And it's very, very powerful to have one canister per user in terms of. Yes, so good point. Essentially, when you create a new canister, it costs cycles. You have to pay for it. I don't remember the cost. I think it's 1 trillion cycle. So it's like around $1 basically to create a canister. But for this week, we are using the playground, so we don't have to pay anything. And so a canister, you can use it for, I mean, this is a very general concept, like in terms of what you can do with WebAssemblies, general computation, general purpose computation. So we've seen people using a canister for a chat application, social application, but also just for NFT collection or like token. There is no real limit to what you can do. Well, what is the difference between a smart contract and a canister? So I've talked about smart contracts, and it seems like canisters are different, but also they share some properties with smart contracts. So that's how you interact with, currently, how you would interact with Ethereum application. So this is Uniswap. It's the biggest decentralized finance like application that we have today. And of course, the application, like the core of the token, like how things work, is on a blockchain, on a smart contract, but not how users access it. So essentially, if you were to use Uniswap, you would have a website, this website on Amazon Web Services. You would probably use MetaMask or any type of wallets from the Chrome Play Store. And actually, there is probably no one is really interacting with Ethereum by the command line and talking directly to the network. They usually use something called Infura, which is an intermediary. And so the canisters, this is not a problem for them because you can get rid of these spots since you can host your website on the canister itself, and the website can be loaded directly by accessing the canister. So you can just use a HTTP request, and we will do that during the week. You will create your own website in a canister. You don't need to have a wallet because, so key difference on Ethereum, when you interact with a contract, you pay fees as a user, which can be very high if we are like in a bull run or like peak excitation period, like can go up to $100 per transaction. On ICP, those canisters, they have credit. So the cycles we've talked about. And so essentially every time a user interacts with a canister, they are just going to burn credit from the canister, but the user doesn't have to pay. So how do you, maybe a good question would be, how do you make an application sustainable, like in that case? We don't know yet what are the best like practices. So you could have a DAO that pays for the computation of the canister. You could have users that are charged in a certain way. It's very open to experimentation. But essentially it gives you more flexibility because if you want to implement fees for your application, you can. But if you want to make an application where users don't pay until they have some functionalities or they have some kind of usage of the platform, you can also do it. And finally, so the goal of this project is to kind of replace those big tech intermediaries. So the Chrome Play Store, you don't need to go to a Chrome Play Store to interact with ICP. You can just use traditional internet protocols. So a big thing about canister is that they are able to be upgraded. Smart contracts, they can never be upgraded. If you want to change, you have to deploy new ones. Canisters, they can be upgraded, and that's really cool because as a developer, when you are creating an application, you always want to add new features or fix bugs. So if you have control over your canister, you can upgrade it. But then I remember that we had some discussions about, but if everyone is going to upgrade their canisters, how is it different than Web 2? Like, because people can just change the code at any point, and if you have token in this application, and the developer decide to upgrade and just like get out with all the tokens, you're basically screwed. So if you are extreme about decentralization, you can black hole your canister. This is very easy to do. And essentially, when you do that, no one can ever upgrade the canister forever. So you're like in a situation where it's very similar to a smart contract. Basically, you can be sure that you will not be, like, the application will never change. But I think it's like limited because you have to get it right. And of course, you cannot make something that evolves. Most applications, they need to evolve. And that's where we have the third model, which is the one that is the topic of the week. How do you make a DAO controlling an application? So in this case, people will vote, there will be proposals, and there will be like open source code that needs to be submitted, and then people can vote and upgrade the application. So yeah, quick recapitulation. Very centralized, but very cool when you have control over your canister. Then very decentralized, but very inflexible would be the black hole situation. And then in the middle is like the DAO situation. So you have a DAO that controls and can upgrade an application. So as I was saying, the goal is also to make sure that the protocol is secure. So if you have multiple nodes, in theory, you can have up to 1/3 of the nodes in a subnet that are malicious. So that's how it's like represented here. If you have 2 nodes or, yeah, like we have 7 nodes here. So it's not a lot. Usually it would be higher than that. But for this explanation, let's say we have 2 malicious nodes and 5 non-malicious nodes. Essentially, whenever like the malicious node would want to change the state of the canister, it would be prevented by the protocol. So a canister is an abstraction, doesn't really exist by itself. Of course, it's replicated across several nodes. And so every time you go through any modification, you have to go through all the nodes. And that's how you make a secure kind of system and also immune to bad actors. If you have more than 1/3 of the nodes that are malicious, then all of the like assumptions that we're making are not correct. So that's something to keep in mind. Yeah, it's like with blockchains. I mean, you have to have the majority of honest nodes. I mean, I think it could be possible. For example, it could be possible if you don't have the right incentives. So it's whole like a game of game theory kind of thing. So, for example, if the application is storing not a lot of like token, like it's kind of worthless, like not a lot of value, then there is not too much incentive to be a malicious node and to, you know, coordinate with other nodes to can steal the code or steal the tokens. But if one day an application is very, very successful and there are a lot of money that is inside and there are more incentives, then yes, that increases the risk. So it's all like a whole game of what is the right amount of decentralization, and also how do you make sure that the nodes are not incentivized to go against the protocol. I think there are quite a few solutions to that. Like, for example, if you make it so that, so right now you don't have to stake anything to join as a node, but there are some networks where you have to because of those reasons. Like, for example, one thing we could do is like you just add like a requirement for all those nodes to stack 1,000 ICP or 10,000 ICP when they join. And if they do something bad and they are detected, you can remove them and you can slash them basically. And that would already be like a first protection layer. Other things could include moving nodes across subnets. So right now it's not the case, but I think it's in the plan and I think it's a really good idea, but basically making it that nodes move across subnets so that they never know what code they are running. And I think it's the end game of the protocol kind of. The fact that nodes just run something, but they have no idea what they're running. And so if they have no idea what they're running, it makes it much more complex to go and try to regulate to break the application. And I mean, last thing would be to have more nodes, but then it costs at a price to have more nodes. It's always like a balance. So what kind of consensus is ICP using? That's a question I always have, and it's different than Bitcoin and Ethereum. So Bitcoin would be proof of work. Ethereum is proof of stake. ICP is none of the two. It's a very kind of custom system. What happened is that you have for each subnet you have a public key. So that's how you can see it here. You have a public key, and the private key associated with this public key is divided into many shares. So each node is going to have one share. And every time you submit a message, like let's say you post a message on social media, those nodes are going to receive the message, process the computation, output the result, and sign their result. And eventually you have 5 out of 7, so in this case 7 nodes that have the same result, they have signed their results, and so you can combine the shares together. So the keys, the key shares, you can combine them, and that makes a whole signature for the subnet. And so in that case, if someone sends a bad result, like they have another result that all the other nodes, it will not matter. But if there are multiple persons that have different results, then it can break the consensus. I don't think it ever happens. Actually, I think it never happened, but yeah, that's basically how it works. So it's just a game of signing. You have different keys that are spread, all of them together, they are combined, and they make like a signature as a message. Yeah. And we can talk a bit more about the consensus. We can go into more details. If you have questions, I'm happy to take them. How does the network scale? So that's a big question, because of course you have multiple subnets. So how does all of this work to make one big cloud where we can deploy as much as we want and we have no limit on the computation? So the network scales by adding subnets, and then subnets, they can easily communicate between each other because of this little fact, that the fact that each subnet has a public key. And so basically this subnet can sign a message, send it to this subnet, and this subnet can know that this message has been signed by this subnet. And so they can just communicate like this. That's basically probably one of the big things that made me go into ICP as much as I did, because I look into other like chains and there was always like a central point. So there is something called the beacon chain in other kind of ecosystem where all the messages have to go through. On ICP, there is no central point. Of course, we need to see if the network can grow. Right now, it's already big, but it's not like thousands of software. It's kind of limited. The question is, not the question, but my assumption is that there is no central piece. So it seems like it can scale because you can just add more subnets. And there is not like one major subnet that will be like a bottleneck for the others. So I think this architecture is good. It's like just direct communication between the subnets. And there is just one thing, which is there is one subnet that stores all the public keys of the other subnet. But it doesn't mean that it's a bottleneck. Like it's just a matter of making things easier. As a user, you only have to like your browser basically only have to save one key, one public key, and then you can just interact with the network like without having to know all the subnets. So the subnet concept, you only get to interact with it if you are a developer or you want to dive into the protocol, but not as a user. You don't need to like know about all the subnets. And so that brings me to the points of the verification. So how do you verify that what you do with the IC is trustworthy? Like that's the whole point of what we're building. It's a trust system. How do you verify when you interact with OpenChat, discover that you are very, like things are trustworthy, like things are happening the way they should be? When you are doing that with Bitcoin, so if you want to verify transactions with Bitcoin without any intermediary, like you just want to be you with your blockchain, you need to download the whole blockchain because you need to do like the whole history of the transactions. And then it will give you the states of the blockchain. And you compare that with what you have. And if it's correct, you know that you are on the right path. On the IC, you only need to have the key. So the key I was talking about, this one, it's just like a public key. It's 48 bytes exactly. And this can be used to verify any message coming from the IC. So when you load a website, you've probably seen this like loader. That's basically when you load a website, you receive a signature that indicates this website has been loaded and certified by GIC. And so the content you receive as a user is signed, and you can verify with the public key that this is the right content that you should receive. So it's really like a super easy way to trust and to indicate that, yeah, to like, to verify locally. Yeah, this is what I wanted to say, to verify locally that one piece of information has been certified by GIC. And that's super powerful. I think it's very underrated feature because you can use that for like IoT devices. They don't have a lot of space or storage. You can use this key to verify any message. And that's super, super powerful. So there is this whole concept of open internet service or DAOs, or you can call them however you want. But basically, this is what is the topic of the week. It's this. We have an application, maybe Motoko Bootcamp or Discover, that is controlled by, that is like running in a set of canisters. This is your dApp. And then you have one canister which governs all of the other canisters. So is able to upgrade or run any kind of operation on this application. And then you create a token system, a way for people to get engaged with the application, a way for people to submit proposals to the application. And you have what's called an open internet service. So it's yeah, it's like a service that runs on its own, that can be upgraded on its own, and there is not one person or one company controlling this application. It's not the case. Oops, sorry. It's not the case of all the applications that exist on GIC. Just want to precise something. Like, sorry. Let's see. Like, actually, all the applications that we know right now, they are not all working like this. So this is a choice. As a developer, you have to kind of give away control of your application to a community. And that's not something that is easy to do. So that's why we don't have, like, OpenChat is running like this, but Discover, I don't think they are running like this, at least for today. So it's like a new pattern that we have to get used to, and a very experimental area of like building things, because we don't know what's going to happen, if the platforms are going to thrive or not, if it's going to work. Yeah, I think that's a picture that basically explains how all the things that a canister can do. So when you see this WebAssembly thing, like WebAssembly module and then the memory here, so this represents the memory and this represents the WebAssembly module. So this is the code and this is the state. And so the code, of course, for example, can be compiled from Motoko. And the state is going to store all the information. So we can store files, videos, pictures, anything you can think about. It's just basically just array of memory, like you can just tap into it. And then that's all the cool features that a canister have. So the first one would be, no, actually, let's start with the browser. So this is like, you can access a canister directly from your browser and you don't need to pay anything. So for example, I have this Whale of Fame from the Motoko Bootcamp. And so I actually lose the state yesterday, but anyway, you have this application and you can see that this is a canister ID and I'm just accessing the canister like from the browser. Like there is nothing between me and the canister. So this is one first thing, and I don't pay anything. The second thing is the fact that a canister can do HTTP out calls. So you can call Web2 services. That's very important because Web3, of course, is not like separated from the rest of the like internet. We still need the Web2 services. For example, if you need the price of some token or if you need the weather for today, you will call an API. And so smart contracts, they cannot extract information outside of the blockchain, which has been a huge problem for making any like big application. Canisters, they can directly call any Web2 services. So you can just do HTTP out calls. There will be an explanation about how it works, but it's pretty easy, just one line of code, and you can call a Web2 service. And the last thing is that a canister is also central to like how crypto works and interacts, because a canister can actually hold assets from other blockchains. So the Web3 world is going multi-chain in the sense of like you have a lot of different projects. And of course, there are monetary, like there are competitions between ecosystems, like my ecosystem is the best. And I'm going to say to you, my ecosystem is the best. Like, but in the end, the way things are moving, we start to see less and less differences between the ecosystems. And we see applications that are actually built on multiple ecosystems. And so one good example of that would be an application like, for example, Discover is built on ICP, but they actually have interacted with, they have integrated with Solana. So Solana is another Web3 ecosystem. And now users from Solana, they can use token from Solana on Discover. And this is possible mainly because on ICP, those canisters, they are able to hold and sign transactions on Bitcoin and Ethereum. So canister can be used as a wallet for other ecosystems. And that's, I think that's super cool because like, yeah, it bridged the gap between what ICP is doing and what Ethereum or Bitcoin have been doing. And that makes for a lot of possibilities. And that's about it. Maybe we have some question. Maybe it's too much. So let's maybe get a bit more concrete. I like this dashboard. So it's a summary of everything that's happening in the ICP world. So we can see, for example, I was talking about those subnets. You have 36 of them, and they are here. And you can see each subnet has an ID, and then a number of nodes that run this subnet, and then a number of canisters that run on this subnet. So for example, here, let's take a look at this one. So we have 13 subnets. You can see exactly where they are in the world. So let's see. Spain? No, there is nothing in Spain. There are some in Switzerland apparently, and Geneva. There are some in US. Well, I cannot. It's very slow. Okay. So yeah, I mean, we have those nodes.
I have counted 12, maybe Australia.
I think it's because there are two here.
Yes, that I counted there.
You have counted there? One. Because you can have two nodes at the same time, actually, at the same place, which is not supposed to be like this, but
maybe some of them are. One of them is two.
We will find this.
What do you need?
There is one in the United States that you didn't check. The one there, that one
I checked all of them.
Yes.
I don't know. That's strange. Maybe. Yeah, no, we didn't miss anything. One day maybe, but yeah, no, we didn't have it. Okay, I don't know. If we look here, we should be able to see them actually. So, Melbourne, yeah, but it's not on the map. No, it's not. No, because those one are for the whole ecosystem. Like it's not the one specific to the subnet I was talking about. Okay, well, anyway. So let's go back. This is what the subnet looks like, and then we can see actually how much canisters have been deployed, what's the finalization rate. So this represents how much block of the blockchain are being finalized per second. So you can see that it's 1 block per second, which is very, very fast. This is most of the time when things are going well, it's very fast. If things start go wrong, like some nodes are moving away, they are sending like malicious information, it can go a bit down, like you can see here. But usually it's around 1 block per second. Then we have the number of cycle burned. So this represents the activity on the network, like how much, because each canister, whenever they are whenever they are working and running and there is computation going on, they burn cycles. And so that represents how much cycle is being burned in the whole subnet per second. And then transactions represent the usage. So how much users, how much query, so how much read and how much updates per second are happening on the subnet. So for example, right now, there are 38 query per second and 8 update per second. So that's some metrics that we can have from the subnet. And what generates the cycle? So the developer, that's what I was saying. Like when you deploy an application, you have to charge it with credits, so with cycles. And so, for example, I can show you like.
You buy it with crack and the ICP.
Yeah. How is it? It's Canister Geek. I was looking for this. So Canister Geek. This is what I use to monitor my cycles, my canisters. So I will show you. Let's say I want to check. Oh, this is so annoying. Let's say I want to check how much cycles I own for one of my canisters. So I will go to this place if it's working. No, it doesn't seem like it wants to work. Okay, I'll try one last time. Okay, so that's my canister for Motoko Bootcamp. And so right now there are 2.97 trillion cycles on it. And so I can see that my canister is burning like 21 million cycles per day. And so at this rate, I have 5,000 days before my cycles will run out. But if they do run out, I will need...
Three cycles?
Yes,
Three?
say it's 10 to the power of 12. And 1 trillion is around $1. So it's not that much, actually. It's very like, yeah.
50,000 days of applications working.
Yes, because
$3.
yeah, $3. Yeah.
You have personally spent $3?
Yes. Yeah. Yeah, I did. Not this one, I think. This is my personal money probably here. Like basically I buy some ICPs, then I burn them to get cycles, and then I have like I think since I've been on the IC, like for 2 years, I've spent around $100 in cycles, basically. That's not a lot. Like there's nothing. What costs a lot is to store a lot of storage for a long period of time. But my application, like the Motoko Bootcamp application, I mean, there is almost no data. It's 2 mega, like, where is it? 3 mega, like it's nothing. And of course, when you do like verification, it costs some cycles, but it's so little. And yeah, we can take a look like
How much will it be for the chat?
for open chats. I don't have access. I don't think this is actually it should be open. We can take a look here.
Any other application?
So we could make a computation, like we could calculate how much they spend per day, because
Is this something you could tell to people before they do?
yeah, completely crazy, yeah. So we could see that, I mean, they have, so those are all the canisters controlled by OpenChat, the DAO OpenChat, they have all those applications they control. And
This is bigger because it's not like.
yeah, they have a lot of canisters because they have a way bigger application. So for example, they have a ledger this is the canister that store their token. They have, I don't know what the index is, but you have the governance, which is the one where they take decisions about the DAO. And then all of them are application that they control. So
See that with the government?
So we could say that the cycles balance is like the dollars they have spent for doing that kind of stuff.
yes,
Okay, so we are in the thousands, 1,000, 2,000, maybe.
yeah, it's 100,000 for them. Like,
Well, this one is 600. That's
Yeah.
the biggest.
yeah,
Maybe two or 3,000 in total.
and
For a whole
this
application.
2,000,
2,000, I can see.
Yeah.
Okay, then maybe 4,000 or 5,000.
yeah. So, I mean, we can take a look at the costs. So this is like a really detailed explanation of the cost for creating canisters, doing computation and so on. And like it's kind of really hard to read. I don't know if they have like a real application example. Okay, if you want.
Can have a look.
Yeah.
Can make
But a good example is if you want to start 1 gigabyte for 1 year, it's $5, around $5. 1 gigabyte for 1 year, $1, $5. And that's really what's costing the most. I think it's really the storage of those canisters, not the computation is not so expensive.
And if you develop an application and then after 1 year you say I don't want to pay again $5 for it, I'm not interested, it's a project that didn't work or whatever, it dies, or what happens to it?
Yes, it will die at some point. So actually it already happens on the community. Like there was a NFT collection, I don't remember the name, but they launched a project, they took the money from people, and then they decided to stop the project because they wanted to do other things. And one day the people in their wallet, they saw that the NFT disappeared, and like everyone was like, what happened, and so on. And basically the canisters was running out of cycles, so there was no cycle anymore. When this happened, there is something called freezing threshold, so the canister will freeze and it doesn't accept new messages anymore. So if you are using the application, you will see like a message coming saying that the application is freeze and you cannot use it at the moment. If no one's put cycles, at some point after, depends on which threshold you have set, but usually it's 1 month, the application will be deleted. And then you lose all the states, you lose everything that you've done. But in this case, the community actually stood up. They like refueled the canister for like the next few years, basically. So like, basically it's a matter of, is the application interesting enough so that people will fund it? Then they will put cycles in it. And otherwise, no. So for example, for OpenChat, the whole entity that is paying for all those canisters and that has the responsibility to refuel in case the application is going down, it's the OpenChat DAO. So essentially they have some ICPs that they have in their treasury here. Whenever one of those canisters is low on cycle, they will burn ICP and they will convert that to credits and they will refuel their cycles. So yeah. If it's your application as a developer, you have to refuel. If it's a DAO, then the DAO has to refuel. If it's if no one is interested in the application, then it will just die at some point. Yeah. So yeah, okay. So let me go back to the home screen. We can see like the number of nodes. So right now it's still like a pretty small network. I mean, that's 1,200 is a good number, but also pretty small in comparison to, I think Bitcoin is like 15,000 nodes. So still like relatively low number, but it's keeps on growing. There are new nodes added. This is the total state of the network. So you can see it's not actually so much. Right now, there are 3 terabytes stored on the IC. You can see how much people have created an internet identity, total supply, like all informations about ICPs are like this public. This is the number of applications deployed. So that's 3,500. Same as before, we can see the whole interaction with the network and the whole activity on the network. So for example, when like we can see if there is something crazy happening, we can see that more people are using and so on. The power consumption of the network is also public, and the transactions for ICP, the proposals. So that's the DAO, like the network. This is how you would, for example, join the network. So you make a proposal, node provider is adding 1 node to the data center. And then if people vote, you get accepted to the network. Yeah, there are a lot of different proposals. We can maybe go into details later. The neurons are the ICP stack, and then the subnets, data centers, node providers, node machine. Quite a few information in the dashboard. Yeah. Do you have a question? No? Okay, I'm just checking the time. We are just on time. Okay. So let me check the chat. Yes, I will repeat in the future the questions that we are asking here. Will you say it's cheap to have your own canister? It's $1 to have your own canister. So yes, I think it's relatively cheap. Yeah, so one node is 10K. The like lower node to run is 10K. And actually nodes provider ICP, you have a whole again a whole like set of documents. So it's this one. I want to see this one. So those are the spec of the nodes. That's Gen 2, we had Gen 1. Gen 1 was like this, so around 32 gigabytes of RAM. Pretty machine. Like it's not like a Raspberry Pi. It's a real node for a data center. So it's around, I remember it's around 10K. And you have different providers, so you can buy one of them.
This is already an investment.
Yes, it's a yes, of course, yes.
Where is the return?
So nodes are being paid in ICP to essentially be nodes. So yeah, you have, so this is the whole like node provider. There is a legal guide and there is a remuneration guide. So you can see that the remuneration, so that's the remuneration per month for one node. And actually, so the IC is trying to be as decentralized as possible. And so we've come up with rewards depending on the geography, because some geography, they have already so much nodes that we don't need, at least for now, more nodes in those geography. The idea is to be like geographically distributed. And so US would be $800 per month, EU would be 1,000, and Asia would be 1,200. And you can also see like all those other jurisdiction, you have different rates. So those are per month. 1 XDR, it's around $1. So you can think of this as in dollar or euro. And then it becomes more complex. Like this is like the current formula. So basically you have a geography multiplier, you have a cost for your nodes over 4 years, and you have a reduction. So like essentially it's complex, like how much you get paid, but I think it's profitable. I mean, this is open to anyone. It's open to anyone. Yeah, you can build the nodes. The only you can build a node if you respect the so the requirements I was saying, like so you have some specs that you need to respect. Like this is the generic specifications, and then we have validated configuration. So those are the ones that essentially have been approved and have been tested in real condition, and they do work. So you have the choice between those different providers. And then this one has been approved by a community member. So like, yeah, those ones I think are the one recommended by Definity. And this one is the one that has been tested by a community member, and apparently has been also validated. So it's not like you can build any kind of node. You have to respect some tables of requirements. But then, yes, after that, essentially you can submit a proposal and you get approved by the network itself, like by the DAO itself of the IC. And so I remember that, I mean, I've been learning that being a node is quite profitable, but also it's less and less profitable. Like basically, the more nodes, the less profitable it's going to be, because like, I mean, it's a whole like economy that is kind of stabilizing. So there was incentive in the beginning to be a node, of course. Now I think it's still profitable and it's still going to be profitable forever, but it's not as interesting. And one last thing about nodes is yeah, I wanted to say something. I don't remember. I wanted to say something. Oh yes, it's limited. Like it's not like any other network where you can join and it's completely like open. You can just enter. You have to be approved by the network, and so this is because you are guaranteed a certain reward every month. And right now, I think there is already too much nodes for how the IC is being used. Like there are some applications on the IC. You can see the burn rate is 8. So we are at 8 billion cycles per second. It's not too bad, but it's not like sustainable. If you add more nodes, you have more costs.
It says average 6 billion, and right now 8 billion. So
it's actually increasing, so you might not see it because I don't know why this thing was in the past, but it's completely destroying the chart.
Anyway, that kind of charts would always be logarithm.
Yes, also yes, and but I mean this is really bad, but you can see that you have more things happening. I remember that
for example, at 3 months or something like it, or 1 year.
Yeah, it's hard because the usage is really random. Like what is interesting is the average, not the peak, because the peaks are. And yeah, I mean for me, I'm pretty sure it's growing quite strong, because I remember that when I was looking at the dashboard like 2 years ago, this was like I would never have seen, of course, this number, and now I see it like every day.
Let's see the graph. 10B, no, because we are in 8B now.
Yeah, we are not in a huge peak. We have seen like 40 billion cycles. I mean, it's quite average right now, yeah. But I mean, yeah, what costs a lot of cycles? I think usually when there are peaks, is because people are uploading things, and that costs a lot. Otherwise, it's just normal activity from the applications and so on. And yeah, I think right now the network is not profitable. So right now it's not profitable, because how much the nodes are paid to how much activity is really happening on the network is negative. So there are more ICPs being created. So yeah, just something to take in mind, to have in mind. Okay, let's close it for now. It's already past 7:05. So I'll see the next session.